Hi students, today we'll discuss about unsaturated hydrocarbons. So unsaturated hydrocarbons means two carbon atoms are more are two carbon atoms connected by a double bond connected by a double bond connected by a double bond or triple bond. Double bond or triple bond are called unsaturated hydrocarbons or unsaturation. That process unsaturation or unsaturated hydrocarbons. So unsaturated hydrocarbons are two types. One is alkenes. Second one is alkynes. So alkenes general formula CnH2n. So this alkenes means double bonded between two carbon atoms. Double bond present in two carbon atoms means that is alkene. Alkyne means triple bond present in two carbon atoms, that is alkyne. So general formula CnH2n minus 2. According to these formulas we can write some alkane like methane, ethane, propane, like we should write. So we can apply first one is alkene. Here if instead of N2 means C2H 2 2s are 4. So this name is ethene. Yesterday already we are discussing saturated hydrocarbons. There last class we are discussing saturated hydrocarbons. In that C2H6 will come, that is ethane. But here instead of two hydrogens one double bond came. How it will come? One C structure I will write. C double bond C, H4 no, one H and one more H, total 4 hydrogens. So 4 hydrogens, 2 carbons, double bond came. So that only ene means double bond, alkene means double bond. Formula is CnH2n. So we instead of n we are taking 2 means C2, 2 into 2 4, H4, ethene. Structural formula is this one. Next instead of n we are taking C3, 3 means C3, 3 into 2, H6, 2 into 3, 6. So C3H6. So that is propane, ene. Structure is 3 carbons like this, 3 hydrogens, 1 hydrogen, remaining 2 hydrogens like this. Each hydrogen we should write like this. But here satisfied this carbon not. So we should mention double bond here. So for carbon everywhere 4 bonds is there means that is satisfied. Carbon atom is satisfied with the bonds. So this is propane. Next if carbon C, C4H how much? 4 into 2 is 8, H8. So this is butene. Structural formula of butene: C 4 carbons, 8 hydrogens, 3 4 5 6 7 8. Again here double bond we should mention. So now every carbon have 4 bonds surrounded, right? Carbon atom surrounded by 4 bonds, 1 2 3 4, 1 2 3 4, like. So this is butene. About alkene, all double bonds. Now we are discussing about alkyne, YNE. So alkyne formula is this one. Instead of this one we are taking 2 means C2H, 2 into 2 4, no, 4 minus 2 2 only, minus 2 is there in formula, so 2 only, C2H2, 2 into 2, and generally N is 2, 2 into 2 4, 4 minus 2 2, so that only C2H2. Structure of C2H2 is C triple bond C, hydrogen, so this name is ethane, YNE, ethane, YNE we are writing. So eth means 2 carbons, no, here also eth means 2 carbons, but ENE means double bond is there in structure, here triple bond is there, so that only YNE. Alkyne means triple bond, no, YNE. Next, instead of 2 we can take 3 means C3H, 6 minus 2 4, H4. So now 1 carbon, 2 carbon, 3 carbons, so somewhere triple bond is there. Here 1 hydrogen, here 3 hydrogens, 1 2 3 hydrogens, so 3 plus 1 4, C3H4, 3 hydrogens, and this is 1 hydrogen, 4 hydrogens, 3 carbon atoms. This is 3 carbons, no, what we will call propane, YNE, Next, instead of 3 we can take 4 means C4H, 8 minus 2 6, H6, then 1 carbon, 2 carbon, 3 carbon, 4 carbons, somewhere triple bond is there, 1 2 3 4 5 6, here 1 hydrogen, so 6 hydrogens total, 6 balanced, so 1 hydrogen, 2 3 4 5 6, so 4 carbons. So this one is 4 carbon means what we will call butene, no, if you double bond means triple bond, no, butane, YNE, butane, YNE. So this is the about unsaturated hydrocarbons. So here some alkynes have some properties that we will see. It is chemically unsaturated hydrocarbons chemically reactive, very reactive, because double bond is there, no, so that only, because unsaturation, it is not a saturated position, so that only unsaturation means reactive only. Saturated means sufficient, unsaturated means that is not a sufficient, yes, like that. It is chemically reactive. This is give yellow flame. These unsaturated hydrocarbons will give yellow flame with lots of black smoke, also. This is because, why it will be black smoke will give, this is because the percentage of carbon is comparatively saturation compounds, comparatively it is very high percentage, high percentage of carbon atom is there, so that only comparatively saturated, unsaturated hydrocarbons carbon atom percentage more is there, so that only not oxidized completely on combustion, not oxidized completely on combustion, so that only it will produce more smoke. So that only you can remember. We are discussing now unsaturated hydrocarbons structural formulas and alkene what to alkyne what, alkene double bond, alkyne triple bond, general formulas also we are discussing. Next, name of these compounds. If only 2 carbons what, 3 carbons what, 4 carbons means what, general chemical reaction, how it is there, reactive or not, it will give smoke or not, it is cleaner or not. But saturated is very clean fuel, saturated hydrocarbons. Unsaturated is not yet that much because of carbon percentage is more in this. Next, structural isomerism. What is the structural isomerism? Organic compounds having the same molecular formula, organic compound having same molecular formula, but same molecular formula but different same molecular formula but different physical and chemical properties, different physical and chemical properties. Organic compounds having the same molecular formula, organic compounds having same molecular formula but different physical and chemical properties. Okay, due to different structures are called structural isomerism, What is structural isomerism? Structural isomerism means organic compounds having same molecular formula but different physical and chemical properties. Due to the different structure are called structural isomerism. Because organic compound structural formula difference is there means it is having different physical and different chemical properties only. How? I will show you some compounds. Difference in structure means it is properties also difference, that only structural isomerism, properties also different. So this structural isomers and this property is called isomerism. Different structural formula are called structural isomers. Structural isomers. This property called isomerism. Structural isomers, compounds having different physical and chemical properties but same molecular formula, it will be showing like structural isomers. Difference in structure, no, structural isomers. So this property is called isomerism. So that's all. So if we look at the structure of butane, means C4H10, this is butane. butane, ANE. Now we should have to write possible isomers of any element means, any compound means we want definitely 4 carbon atoms. 4 carbon atoms compound only it is possible. If 3 means 1, 2, 3. That's all. If you want to write like this means both are same. 1, 2, 3 carbon, 1, 2, 3 carbon. Both are same. So that only we want at least 4 carbon atoms means we will write. So what is the structural isomers of butane? So I will write. We found that 2 different skeletons are possible with our 4 carbon atoms. 2 only possible. What is that 4 skeleton diagrams? See, I will show you like 1, 2, 3 and 4. This is one, no? 1, 2, 3, 4. This is one thing. See, both are 4 carbons only. 1, 2, 3, 4 carbon. 1, 2, 3, 4. Sorry. This one you can remove. 1, 2, 3, 4 carbons. But here difference is structural arrangement. This is a line linear. This is a somewhat branch. So like this is there. So extra any we can change in this one structural formula. No, same. This is one. This is one thing. No extra structural isomers possible for this one. Only 2 isomers possible. 4 carbons okay. 10 hydrogens where you have doubt. So I will show you. CH3 first one like this. Next one CH2. Next carbon also CH2. Next CH3. Yes, na. The 3 plus 3, 6 plus 4, 10. This is this structure. This structure we want. Next this structure. 1 carbon, hydrogen, hydrogen and hydrogen. Next 1 carbon, 1 hydrogen, 1 more, and this is 1 more carbon. Hydrogen, 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 hydrogen. See now 1, 2, 3, 4 carbons. 3 plus 3, 6. 6 plus 3, 9. 9 plus 1, 10. This is also 1. So only 2 structural isomers possible for C4H10. C4H10 butane. So now I will take one more example. That is isomer of hexane. Isomer of hexane. Hexa means 6 carbons. Hexane means 6 carbons. See how many it is possible. See 1, 2, 3, 4, 5, 6 carbons. Here hydrogen atoms like this is there. So I want to show you like this. Hydrogens is there. How many hydrogens is there? 1, 2, 3, 4, 5, 6 carbon atoms. 3 and 3, 6 hydrogen atoms. 4 plus 4, 8. 6 plus 8, 6 and 8, 14. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 hydrogen atoms. C6H14. C6H14. This is one possible structure. Second one I will take carbon, 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 carbon. 1, 2, 3, 4, 5. Next one is here. I am taking carbon. So hydrogens is there. If you want, you can this bonds only hydrogen bonds. I won't represent again and again hydrogens. This is one structure. So see here I want to write down or above also same formula will come. This side 2 carbon, this side 2 carbon, middle carbon having 1 more carbon. Totally 5 plus 1, 6. 14 hydrogens will come. You can check otherwise. Third one carbon, 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 carbon and carbon. Here 1 carbon. See difference is there, no? This one belongs to that carbon. Okay. Here 1 hydrogen, we want to represent this one. 1, 2, 3, 1, 2, 3. This is one more structure. See here carbon atom having numbering also I will give for no confusion. 1 2 3 4 5 carbons. This is sixth one. So this carbon contains third carbon. Now 1 2 3 4, this side I give this carbon containing, this carbon having which carbon? Second carbon having branch. Here third carbon having branch. If I am writing this carbon here na, same formula will come. If this carbon I am writing here na, here means this side you can take 1 2 second carbon, second atom having carbon chain, carbon branch, like both are same. Here I want to write this carbon here or here, both are same. This carbon here and above same. So this 3 only possible. Next one more 2 is possible. I will show you that. That is fourth one. C, C and C. One more carbon, 4 carbons. Here one carbon, here one carbon is there. See how many hydrogens? See 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one also 14 carbons possible for in hydrogens possible to keep there. So this is one more. See, this is different, not this previous 3. This is different. So like fifth one also having C, 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 4 carbons. Here one C, here one C. See, 6 hydrogens plus 9, 10, 11, 12, 13, 14. This is different. See, this 5 only possible for C6H14 isomer is a isomer of hexane. 5 isomers possible, that 5 only this one. So we want to write anything here. This carbon right here means this carbon here, same carbon have 2 carbon atoms. This carbon here we want to write a same formula. This is also will come. See, 1 2 second carbon having functional group, second carbon having one more carbon chain. So this carbon we want to write here means second carbon also having this side to this is second carbon. So this both are different, but when we are writing here, then both are same will come. Yes, no. This one we want to write here, this one will come. This one we want to write here, this one will come. Both are same. This is normal. So 5 only possible. Thank you. Next class we'll discuss about functional groups.